Hi everyone, I am Amsavini, Assistant Professor ECE, Nanda College of Technology. Today we are going to see about p-n junction diode. In that we are going to see the definition, introduction, formation of p-n junction, conditions of p-n junction diode, forward bias and reverse bias. Definition. A p-n junction diode is a two-terminal semiconductor device. It allows current in only one direction. It has two terminals, one is anode, another one is cathode. Anode represents positive, cathode represents negative. This p-n junction diode is formed by a semiconductor, p-type and an n-type semiconductor. P-type and n-type semiconductors are made from semiconductors by the process called doping. If we add an pentavalent impurities, it becomes a p-type semiconductor. If we add trivalent impurities, it will become an n-type semiconductor. These two semiconductors are fabricated by a special fabrication process uh, for making p-n junction. In p-n junction, p-type materials having majority charge carriers as holes. In n-type semiconductor, majority charge carriers are electrons. If we combine these two semiconductors, holes from p-type material moves towards that n-type semiconductor. Electrons from the n-type semiconductor moves towards that p-type semiconductor material. After a certain time, a boundary is formed between this p-type material and n-type material. That is called depletion region. Next, we are going to see about the conditions of p-n junction diode. Without biasing, this p-n junction diode do not conduct. That is called zero bias. No external voltage applied to the p-n junction diode, it will not conduct. But it conduct in forward bias. Forward bias means the positive terminal of the battery is connected to the p-type semiconductor and negative terminal of the battery is connected to the n-type semiconductor. In reverse bias means the negative terminal of battery is connected to the positive terminal of positive p-type semiconductor and the positive terminal is connected to the n-type semiconductor. The connections of forward bias is shown in this figure. In forward bias, negative terminal of battery is connected to the n-type semiconductor. Positive terminal of battery is connected to the p-type semiconductor. If we conduct like this, negative terminal of the battery will give a negative charge. The negative charges will be repelled by the n-type semiconductor electrons. This will moves electrons towards that p-type semiconductor material. In the opposite side, p-type having holes, that will be reflected by the positive terminal of the battery. If both the charge carriers moves, then recombination takes place, and after a certain time, electrons will cross that depletion region and the current flow starts. In that we are going to see that two regions. First one is depletion region, that is between that n-type and p-type semiconductor. It will it will be overcome by the forward bias. Then in reverse bias, n-type semiconductor is connected with the positive terminal of battery, p-type semiconductor is connected with the negative terminal of the battery. If we conductor like this, positive terminal is attracted by that electrons and the negative terminal will be attracted by holes. The depletion region width will be increases. No current flow occurs in that reverse bias. That's all. We will see remaining in next video.